Alright, so if the previous section is not enough or sufficient to explain my idea, here are some more technical stuffs. Alright, in this section, I'm gonna assume that you have some light background of artificial intelligence, or if you don't, it's okay though. Now, what is decision tree? So, decision tree is a supervised learning algorithms used for classification and regression tasks, which I use it as a classifier in this idea. The main idea of decision trees is to find those descriptive features which contain the most information. The most information regarding the target feature, and then split the dataset along the values of these features such that the target features values for the resulting subdatasets are as pure as possible. The descriptive feature which leaves the target feature most purely is said to be the most informative one. Okay, that's some background of decision tree. And tree, how come it's called as tree? So once upon a time, there's a single decision node called root node. Yeah, I know it's single. Then it assigns some attributes and have two or more decision nodes. And each of it assigned with some more attributes and having some branches. And voila, it's look like tree a bit, you know. And so it's called tree because it's like a flowchart like tree structure, where an internal node represents a feature or attributes or characteristics or whatever you call it, and the branch represents a decision rule, and each leaf node represents the outcome. The topmost node, as I called before, is known as the root node, and this flowchart-like structure helps you in decision making. You know, it's visualization like a flowchart diagram, which easily mimics the human level thinking. That's why these decision trees are easy to understand and interpret. And decision tree is a white box type machine learning algorithm, means that it shares information about internal decision-making logic, which is not available in the black box type of algorithms such as neural network that doesn't allow user to see its learning decision-making logic. Its training time is faster compared to the neural network algorithm, since the complexity of the algorithm is less complex, it's much simpler, and it's a distribution-free or non-parametric method which doesn't depend upon probability distribution assumption. Decision trees can handle high-dimensional data with good accuracy. And the basic idea of any decision tree algorithm is as follows. So there is a data set, of course, like a pretty huge data set. And then we split it into the training data and testing data with, some equal weight. Not, we try to distribute the weight or the parameters equally. And then we select the best attribute using attribute selection measures, or ASM, to split the records. And this ASM is a heuristic for selecting the splitting criterion that partition data into the best possible manner. It's also known as splitting rules because it helps us to determine breakpoints for tuples or on a given node. ASM provides a rank to each feature or attribute by explaining the given dataset. Best score attribute will be selected as a splitting attribute or source, and in this case of a continuous valued attribute, split points for branches also need to define. Most popular selection measures are information gain or gain index or gain ratio. And then we make sure that the attribute a decision node and breaks the dataset into smaller subsets, and then we start building the tree model by repeating this process recursively for each child until one of the condition will match. The first of the tuples belongs to the same attribute values, or there are no more remaining attributes, or there are no more instances. And then we evaluate the model and test the accuracy, precision, and recall with the testing data. And after that, let's do some execution. So to execute this project, the first, of course, we have to build the decision tree model as the previous slide, and then we import the libraries into the system, and we get the hard disease dataset, and we load the data, and we do some feature selection. Oh, by the way, feature selection is a term that is the process of choosing some significance parameters or attributes, or obviously features. And for this hard value, there are age, gender, weight, blood pressure, heart rate, oxygen saturation, atrial fibrillation, ventricular tachycardia, and comorbidities such as diabetes, thyroid disease, kidney disease, etc. And the prevalence, or how significant a parameter is, will be determined by cardiologist. And after we select the features, we split the data into training and testing data, and we build the decision tree model as previous slide, and we evaluate the model, and we apply the model to the real case. Now for the real case, we will get some data inputs, including anamnesis and like fresh data such as blood pressure or heart rate, and then it will be fed into the decision tree model, and the model will determine if you have, oh, by the way, if you have no symptoms before in the anamnesis, this model will decide if you have heart failure symptoms or not. If you still have no symptoms, it will keep monitoring your vital signs. And if once you have heart failure symptoms and you check it to the doctor and the doctor says yes, I mean, if you are judged with a heart failure symptoms, it will be fed into the anamnesis. So after that time, you will be considered as a heart failure patient. So you will have to output. If you have some chest pain and the symptoms are severe, the system will call the ambulance and the nearest hospital and call your assistants. And if you have light symptoms, the system will hold a phone call with the doctor, and if necessary, will provide you guided meditation, like with some psychologist, and of course call your assistant to assist you. So that is my idea of this technical stuff. Yeah.